Let's continue with lesson 3.9. Hopefully you've just watched the video describing how to use the graphing calculator to find the line of best fit and that correlation coefficient, because we'll be talking about that at the end. So let's go ahead, number 5, and use the information we found from our calculator to write the equation. Y equals, I believe for the slope we got 20.8 x plus our y-intercept, which was 41.4. Number 6 then asks us to use this equation to predict the number of calories in two different burgers. One is a Whataburger, and the other one is, we're using this today, sorry, I misspoke. They want us to use our equation that we found in number 4 and the equation we just found now to estimate how many calories should be in a Whataburger. So the equation we found in question 4 was y equals 25x plus 0, while the equation from the calculator, which is probably going to be more accurate, it should be, was y equals 20.8x plus 41.4. We are now going to write these equations, but we're going to replace x with 25 because we're told there's 25 grams of fat. So for our first one, we're going to have y equals 25, but now instead of x, we're going to have the 25 grams of fat. Everything else in the equation stays exactly as it was. We're going to do the same thing for the calculator generated equation, keeping it exactly as it was, except replacing x with 25. It didn't change colors for me. So the answer we get from our equation is 625 calories. The answer we get from the equation that we calculated was 561.8. Sorry. Right. Sorry. What is this one? 0.4. Yeah, I wrote the wrong. 0.4. I wrote the wrong thing down. Calories. They told us that the Whataburger actually has 590 calories. Which line gave the more accurate prediction? It appears the one from the calculator gave the more accurate prediction. It's a little too low. The one that we created was way too high, but it looks like the calculator is a little bit closer. Moving on to number 7. Again, we're going to be using the equation that we generated with our calculator. So the y equals 20.8x plus 41.4. This time they say an Arby's, roast beef sandwich from Arby's has 360 calories and 14 grams of fat. So we're going to replace x this time with 14. Keeping everything else the same except what we replaced x with. And when we calculate that, we do get 332.6 calories. What does our line of best fit predict? It would be slightly different. But so our line of best fit from the calculator is 332.6. The actual roast beef sandwich, not a burger, has 360. Our line of best fit is predicting a little bit too low. It's fairly close. It's a reasonable estimate, though. Another piece of information your calculator gave you when we did the calculator exercise was this idea of correlation coefficient. You noticed that your calculator had an R and an R squared. We worked through the first half of this, so if you need to go back and watch the video to make sure you have the R showing up in your calculator, go back and watch the TI-84 video, and it should show you how to do it. We'll talk a little more specifically about R's as we get to the end of this lesson. We have two scatter plots here given to you, and they're talking about correlation coefficient. Correlation coefficient, the closer we are to 1 or -1, the more accurately the data is being modeled by the line of best fit. Think of these as percents. 1 would be 100%. That would be 100% of my points are on the actual line of best fit. So the closer we are to that 1, the closer the data is to the line. Number 8 asks us, one of these scatter plots has a correlation coefficient of 0.19. The other has a correlation coefficient of 0.82. Again, thinking about these as percents, that would indicate that one of them has 19% of the points on the line of best fit. The other one has 82% of the points on the line of best fit. Which one do you think is which? First graph, do you think that is the 0.019 or the 0.082? I would guess it's the 0.82 because those data points are very close together, which would leave this other one as 0.19. The data is not as consistently in a straight line. Might be some other type of regression, but probably not a linear regression. Number 9 says then, okay, let's actually put real data to this and see what we think would go with each one. Number 9 says one of the scatter plots has the homework score on the x-axis and their grade in the class, their percentage in the class on the y-axis. The other one still has the grade on the y-axis, but now instead of their homework score, we've now put their name alphabetically. So the first person in the class alphabetically is number 1, the second person in the class is number 2, and so on. Which one do you think is which? So the graph on the left, lost the E there. Do you think that is the one that compares homework score to grade or last name to grade?
Probably homework score.
I think homework score would be correct. I don't think your last name is going to say a whole lot of how you're going to do in the class unless you're sitting in the back of the room. The graph on the right is probably the one that has to do with last name. Going back to our calculator, what did we determine as the correlation coefficient for the line of best fit we created? Rounding to 2 decimal places. I believe we got 0.898. Just a quick review of how to round. I know that's always challenging at times. What does the 8 tell the 9 to do? Well, it would tell the 9 to go up, but when a 9 goes up, it goes up to a 10, which means I have to carry the 1. 8 plus 1 is 9. My correlation coefficient is 0.90, saying that 90% of the data are within the line of best fit. That's a pretty high R. It's a pretty good correlation. It means that it's a pretty good line of best fit. At this point, you can start working on the group work on page 415.